Good evening, everyone. My name is David Carr, and I'm president of Regis Jesuit High School, and it's my pleasure to welcome you here this evening. We're pleased to have with us this evening the curator of the Vatican's meteorite collection, one of the world's largest. And you thought they just collected relics. Brother Guy Consolmango became astronomer and professor of astronomy before deciding in 1983 to join the Peace Corps as a way to contribute to the world outside the world of university. In 1989, he returned to his devout Catholic upbringing and an early desire to join the Society of Jesus, and we're delighted to call him one of our own. 2 years later, he was called to the Vatican Observatory at Consolmango, Italy, the Pope's summer home, to do astronomical research. Brother Guy divides the scene between Consolmango and the Vatican's Observatory on Mount Graham near Tucson, Arizona, where he studies the Edward Cooper belt of planetoids. Often referring to himself as a missionary of science, he travels widely and was part of the team of astronomers who determined that Pluto is no longer a planet at the meeting of the International Astronomical Union in Prague in 2006. Please help me give a warm welcome to Brother Guy.
Thank you very much. Thank you. Thank you all for showing up. It's great to have you here on a Thursday night, which can't be all that exciting a time to come out. What I want to talk about is the role between science and faith in my life, in the life of people who I've worked with. I guess I have to talk from back here. You see, there's noises from heaven that direct where we have to stand. I'm a Jesuit, I'm a scientist. I don't think it's any surprise to anybody here that, as far as I'm concerned, there's no conflict. I'm not a conflicted person. And speaking about science and religion, I find the most difficult thing for me is to try to figure out where people are coming from who think there is a conflict, because I've never experienced it. And indeed, you know, my teachers were all very religious people of different denominations. My thesis advisor at MIT was a devout Mormon. Where does this come from? More than that, however, as I dig into the question, I've come to realize that the fact that we do science, not just that I do science, but that we do science, depends on a religious faith. I'm going to explore that tonight. Before I do that, though, because I'm from the Vatican Observatory, and to correct our esteemed president, I'm the former curator of meteorites, because Pope Francis did a terrible thing to me a year ago, September, and made me the director of the observatory. So now I have to do the same sorts of things you do, which I sympathize. I've got, a dozen Jesuits who I'm supposedly leading. Right, it's like having a dozen cats. Because people are interested in the Vatican Observatory, I've got a little film clip that I'm going to show. It's about 5 minutes. It explains our history, what we do, and the narrator can probably explain this much better than I can, so I'll turn it over to him.
Both science and religion have conversations about the universe. They're ways of learning how we interact with this universe. It's not just a question, is there a God? There is a God, how do we get it? It's not just a question of, there are a bunch of stars. Rather, why are there stars? How do they work? How does that tell us how things work on Earth? The interaction that I see when I'm learning is that religion gives me the reason to do the science. Back in the papacy before Francis was Benedict, and one of his lines in the final allocution to the father of the general congregation was, go with the frontiers. Well, there is more frontier than 3.7 billion years away. The first official leaders of the church were formally started in 1582 with the reform of the calendar. Then in 1891, Pope Leo XIII wanted to come to show that the church is not against science, but the church follows science. It's still relevant. It's also some limits. And then the walls surrounding the Vatican, as the city lights grow, and as the Italian government did from that, the territory of Consolmango, In the 30s, they built new telescopes on the roof of the Papal Palace in Cathedral as telescopes in the in the 1930s. By the 1980s, light pollution makes those telescopes unusable, so we built new telescopes in the north side of Arizona.
I'm working in 3 projects. The first one is near object. So what I'm doing with needles is just observe them using modern telescopic parts. The second project is meteors, very meteors, what we call shooting stars. And the third project is set fireball network. And we will have 4 cameras here around Jerusalem, so that they can take fireball into the atmosphere, the region. This telescope, that an advanced technology telescope, it was the first of the new technology telescopes that has been considered pretty much the norm in developing telescopes. With the advance of computer technology, we had the capability of bringing that advanced technology directly into our telescope. So it's an expandable. It's almost like it's a living machine, so it can grow as technology grows. It is still very important to maintain scientific research simply because there is still a lot of confusion about this relationship between science and faith. We're not out here trying to prove the existence of God by looking at the telescope. That's not what we're doing. But we can say that if we want to attain the reasonable results looking at that telescope, we need to do it embracing a certain work ethics that is, in fact, the same work ethics that the Bible itself tells us through the commandments and through the Gospels to embrace. Human beings look at the stars and wonder. They want to know, what is that? What is that about? How do I fit in? They hear about the planet and they want to know, what is that like? If we're part of the human race, we're part of the race that went to the moon. We're part of the species that looked at the stars and went, what the heck are those things? Looking at the sky reminds you that there's more to the universe than what's to watch. What's more, if you believe in the universe, that God so loved that He sent His Son, that not only are you allowed to study the universe because it's kind of cool, it's an act of worship. It's an act of getting closer to the Creator and getting closer to a universe, as the definition said 200 years ago, was cleansed and clean by the incarnation. Then, doing science is an act of worship.
Should point out the mention of the foundation. I have another job, another hat to wear, which is president of the Vatican Observatory Foundation. And that's the outfit that raises money to keep our telescopes going and to run special events such as summer schools and other outreach programs. So what I'm doing here is to basically let you know about the observatory. Now, the role between science and faith has a lot of different aspects to it. Paul Gabor in the film mentioned about doing science with the same ethics. I'm actually not going to be talking about that. I'm not going to be saying the obvious that if you don't have an ethical way of doing science, you can't do science. It's true that most of what we think of as ethics comes from our religion, what we forget is that that's unusual. The Jews were very proud of the fact that God gave them their law, because most other religions didn't get a law from their gods. They had gods and they had a theology and they had a cosmology, and laws were just, something else that maybe a king came up with. Furthermore, there are plenty of scientists who claim not to believe in God who nonetheless recognize you have to behave ethically. You can't fake your data. You can't cheat about where you got your information from and expect science to continue to function. That's all very practical. But that's not what I mean by the need for science to have faith. So, if I'm not using faith as a source of moral guidance, then what is the reason why science needs faith? I'd say there are three fundamental reasons why science is based on belief. First of all, I remind you a fact that anyone who studied logic knows: every logical system must begin with axioms, with things you assume. And you choose your axioms and you can prove anything you want. To my point of view, God is not something that is proved at the end of so long syllogism. God is one of those assumptions. Let's assume there's a creator God. What does that do to the way we look at the universe? And you can say whether it's consistent or inconsistent with the universe we see, but at least we're recognizing God isn't subject to my logic. God is something I will assume, and you can assume no God, and then look at the universe and see what effect does that have on the way I look at the universe. But I'm going to be more specific than that. There are three axioms to science that if you don't believe, you can't do the science, but which are specifically religious axioms, by which I mean I can identify some religions that don't have these axioms. The idea that there is a real universe, that it follows laws, that it's worthwhile. Think about this assumption of realism, that the universe really exists. There's a famous story of the Chinese Taoist Zhao Jing. And to read it goes, once Zhao Jing dreamt he was a butterfly flittering and fluttering around, happy with himself, doing as he pleased. He didn't know he was a Zhao Jing. And then he woke up, and there he was, solidly and unmistakably Zhao Jing. But he didn't know. Was he Zhao Jing who had dreamt he was a butterfly? Or was he a butterfly dreaming he was Zhao Jing? And he's got a point. Maybe everything is an illusion. There's a whole philosophy called solipsism that says that I'm the only thing that exists and all of you people are the projection of my imagination. The story goes that George Bernard Shaw was giving a lecture once, mentioned solipsism, and someone in the audience came up and said, but I am a solipsist, and so are all of my friends. Yeah. We have to assume that there is a physical reality, knowing full well that our ability to perceive that reality is strongly limited by the limits of our senses. But even people who do quantum physics, who might argue about what is reality at a certain level, nonetheless they have to accept that the physical manifestation of the needles in their instruments are actually showing things. They're real, even if the reality that they're showing is still kind of hard to understand. If you don't have that assumption, you've got nothing to study. Or at least what you wind up studying isn't physics anymore, it's metaphysics. And if you think that affects the way you study, I remind you of this XKCD comic. The character goes, I don't understand how my brain works, but my brain is what I rely on to understand how things work. Is that a problem? I don't know. How can we study the tools we use to study? How can we can't recurse. We have to assume that there is a physical universe, knowing that there are branches of some religions that would say that everything is an illusion. You want to say everything's an illusion? You can be a very, very spiritual person. Hard to do that and be a physical scientist. More than that, you've got to believe that nature follows regular laws, and not every religion believes that. Consider the nature gods of ancient Greece and Rome. This is a Chalcedonian painted vase from about 550 BC, and it's illustrating a scene from the ancient legend made famous 100 years later in the play Prometheus Bound, Aeschylus play. To quote the scene, "The earth-born dweller of the Cilician caves was impetuous Typhon. He withstood all the gods, hissing out terror with horrid jaws, while from his eyes lightened a hideous glare, as though he would storm by force the sovereignty of Zeus in the sky. But the unsleeping bolt of Zeus came upon him." So, you've got in the picture Zeus with the lightning bolts, that's off to the left, and then the monster glaring and hissing at him. Cilicia, where's Cilicia? Cilicia is this region of what we call southern Turkey, and it's bounded by mountains, and notice what you find in the mountains. The boundary, all those dots there, are volcanoes. Think volcanoes. Listen again to the description of that monster under the ground, hissing out terror with horrid jaws, while from his eyes there was a hideous glare. Fire and smoke rising up into the sky, challenging the realm of Zeus. And what do you see when volcanoes erupt? Lightning bolts coming in the other direction. This was taken in 2010 from that famous volcano in Iceland with the unpronounceable name. Now, I'm a scientist. I can explain why you get bolts of lightning whenever there's a volcano. It's because the dust, the fine dust, provides an electrically conducting path, and I can use Maxwell's equations to work out why these things happen. To the ancients, what they're looking at here is a battle between the monster under the mountains, Typhon, and Zeus, the god in the air who throws the lightning bolts. Notice the gleaming eyes of the monster that you can see in the clouds there. Now, if you think that volcanoes erupt because there's a monster under the mountain, and the lightning strikes the mountain because there's a god up in the clouds throwing lightning bolts, you have just explained everything that's in this picture. And you've got an explanation that works perfectly. And in fact, an explanation that can explain anything in nature. What happens in nature? Some nature god decided to make that happen. I cannot disprove that. But if I accept that as the explanation for everything that happens in nature, I'm never going to be a scientist. The Romans were great engineers. I see their aqueducts to this day when I go from Castel Gandolfo into Rome. But the Romans were not people who were interested in pursuing questions of science. On the other hand, if you have a religion that denies the existence of nature gods, two things are going to happen. First of all, the culture that believes in the nature gods are going to say you're an atheist, and atheists are dangerous, and we'd better get rid of you by throwing you to the lions. And you go, no, actually I believe in one God. Yeah, right, sure. You don't believe in our gods. That's the point. The other thing that will happen, though, once you get rid of the nature gods and only have one God who happens to be supernatural, then you've got a problem. How do you explain this stuff? People who didn't believe in Zeus, why, they're crazy. Look, there he is. And you say, well, no, actually, that's the solution to Maxwell's equations. You've got to believe that there are equations to be found, that there is a solution to explain nature other than a nature god. Once you get rid of the nature gods, you've got room for science. If you don't, you have... Who was the first person to think that there might be laws of nature to describe nature? You know, we believe in nature, we believe in laws of nature now because we learn them in school. They do a great job of explaining things. They allow us to make buildings that don't fall down and light bulbs that light up when I flip a switch. Who was the first person to go looking for laws of nature? You might argue that Aristotle was. But the interesting thing is, though Aristotle had a description of how the universe worked, he never attempted to have a predictive power to that description, and nothing really developed for another 1,500 years after he wrote up his explanation of how the universe worked. When does science, the other person you might think of as a Roman scientist, Ptolemy, was actually just trying to work out the positions of planets so that he could cast horoscopes better. Make a living doing that. And besides, he wasn't a Roman, he was a Greek living in Egypt. When did science actually get started? Science is a big effort. Science requires a bunch of people who are not busy growing crops or doing useful things, but are nonetheless being supported to sit around and ponder the universe. And that only happens when you've got a culture that's rich enough to afford to be able to let these useless boffins who, let's face it, I don't trust any of the crops they grow because their heads are in the clouds anyway. When did that finally happen? It actually got started first in the 13th century in the medieval universities, and then the Black Death came through, the plague, which wiped out a third of the population of Europe. Europe was no longer big enough to support that kind of effort. The universities stumbled along basically teaching what had been done, and it wasn't until the population had completely recovered, which was around the end of the 1500s, that science got started once again. Where did it happen? It happened in the medieval universities. And the universities were founded by the church as a way of training people to be priests and other clerics, and also to train people in the useful skills of commerce and the rest, as commerce and the rest became important. But they were a place where scholars could get together, where they could have a conversation with each other. Albert the Great was one of the first in the early 13th century, Roger Bacon, and then we really had to wait until the Renaissance picked up. One of the things in the early 13th century, well, late 13th century, was this image from Bishop Tempier. The universities were basically just getting put together. And the big impetus to make a university was that as the Christians were reconquering Spain, they managed to capture the Arabic library at the University of Toledo. And there they found Arabic copies of ancient Greek books like Aristotle, which they then translated back into Latin. And these formed the basis of what was taught at the universities. So you suddenly had a group of theologians who had Christian theology and a group of philosophers who had ancient Greek philosophy, and the two were beginning to butt heads. Aristotle assumed the universe was infinite and infinitely, ancient, without a beginning. Christianity says, no, the universe does have a beginning. Who's right? Bishop Tempier forms the first blow for modern science by saying that the philosophers cannot stop the theologians from raising questions. That, in fact, there are a large number of items such as theology is useless, don't bother studying theology, which he doesn't want the people in the University of Paris to teach. The idea that there is only one universe is fine, but that can't be said to say that God couldn't create other universes. So there is an impetus to start looking beyond, for the first time, beyond Aristotle's understanding of the physical universe. In addition, Thomas Aquinas, very, very clever man, was able to show how the principles of Aristotelian philosophy could actually be seen to underpin Christian theology, and that there was no essential contradiction between the two. But even as that is happening, John Buridan is writing about ideas that we would later recognize as the Newtonian idea of momentum, And Nicholas Arim writes this wonderful book about the relative motions of the earth and the sky. For instance, Nicholas Arim writes in one of his books that logic alone cannot tell you that the earth is standing still and the stars are rising and setting, or that the stars are standing still and the earth is spinning, causing them to look like they're rising and setting, which anticipates, Copernicus by several hundred years. He then goes on to say, but of course everybody knows the earth is standing still. This shows you merely the limits of logic, that you could possibly believe the opposite. So he was kind of there, but not quite there. Nicholas of Cusa talks about a universe where every star could be another world, a place where there could indeed be other inhabitants. All of these ideas are generated in the medieval universities. The modern study of astronomy is actually a key part of the university, because the way that you're going to be, if you're going to learn things, there are 3 stages you go through. You go through grammar school, where you learn grammar, rhetoric, and dialectic. In other words, you learn how to talk and express yourself. And then the quadrivium, where you learn the more advanced topics of arithmetic, geometry, astronomy, and music. Astronomy is one of the 4 courses of the quadrivium. But it's actually, in a sense, it's a basis on which you're going to build natural philosophy, because they thought that the motions of the stars mimic the motions of angels. And only then, after you've mastered these sets of courses, so you've got grammar school and you've got high school, finally you get to the university where you can get a doctorate, or at least a master, in either science, or philosophy I should say, or theology. That was the ancient medieval university. Of course, we don't have that anymore. Our universities are totally different. The highest degree you get nowadays is not a doctorate of philosophy after, well, actually, yeah, I got a PhD, don't I? But it's not as if people are going around in ancient black robes and hats when they get their degrees, like, actually, maybe we do. We owe our system not only of educating people, but of letting other people know that you've been educated. It all comes from the Middle Ages, from the church. So that I've got a doctorate from the University of Arizona. Now, most of you probably have never attended the University of Arizona, but if you want to know that I am a certified PhD, you trust that the university degree is as good as a degree from the University of Colorado, the University of Nebraska, the University of, well, any place that has the same ordered set of classes and the same procedure of bringing students from the miserable ignorance that they have when they're freshmen at Regis High School to the glorious brilliance they have when they've graduated from Regis University. Our religion also allows us to assume the universe is real, but rejects nature God, so we have an explanation for why nature works. But there's a third thing that it does. It says that studying the physical universe is a worthwhile thing for grown-ups to do. And not just because it's going to make you rich because you can invent Teflon or write software. Just knowing how the universe works is worthwhile to a large enough chunk of the society that they'll pay you to do it, originally because they recognized creation as an expression of God. Since the beginning of time, God has expressed himself in the things he has created. Do we have any Protestants in the audience who recognize that? I know Catholics never know the Bible. It's Paul's letter to the Romans, chapter 1, verse 21. That sense that the society is willing to support you is an essential part of the necessity, and not every religion has that. I'll give you an example. I gave a talk, 15 years ago, about Jupiter and the moons of Jupiter at this lovely school, College of Charleston, South Carolina. And my background is geology. I was doing geology of other planets. Kid comes up to me, undergraduate. That was a great talk. He's, oh, I like that. I remember him saying that. That's nice. He says, I'm really excited about what you're talking about. He says, I want to be a geologist. Yeah, great. This is, what I was trying to do. And then he says, so what do I tell my mom? South Carolina, Bible Belt. He's coming from a culture where being a scientist is not something that his mom is going to be proud of, but something his mom is going to be ashamed of. What are the odds that he will be able to persevere and get a doctorate? They're a lot thinner because everybody that he grew up with is going to see him as a traitor to his culture and his version of Christianity, his religion. How many great scientists have we lost by people who have insisted there's a war between the two, and most people don't know science, they know their religion, and if they're told they're going to have to choose between the two, they'll choose the thing they know. To give you a sense of how important that is, India. Think of India. There's 1.2 billion people in India. And India has been known to have some nice mountains, right? Even better mountains in Colorado. Presumably you can go skiing in those mountains. Here's an Indian skier. Of the 1.2 billion people in India, how many have ever won a gold medal in the Winter Olympics? You know the answer? 0. It's not because they're not good athletes. Lord, if you follow cricket, they're fabulous at that. It's because moms in India don't have dreams of their daughters being figure skaters. Dads in India don't have dreams of their kids winning downhill races. It's not part of the culture. It's not the kind of thing where you're going to have schools to train people how to do this. It's not the sort of thing where you're going to have coaches who know how to get people up to Olympic caliber. It just isn't part of the culture. And in the same way, if you don't have a culture that thinks that science is wonderful, you're not going to have the support of the family. Scientists are people. We do things out of love. We do things out of desire. We do things that come out of the families that we grow up with. I want my mom to be proud of me. And I grew up in a family where mom and dad thought being a scientist was great, so it was really easy for me. I never really appreciated how easy it was until I ran into other people who didn't have it so easy. One of my fellow friends in grad school, grad school, every now and then you're just going to hit a brick wall where you say, I don't understand this. This doesn't make any sense. I've got to pass this course, but I don't get it. For me, I'd hit that brick wall, step back, and rather than saying, well, I guess I can't do it, I'd look at my hand with the MIT ring and said, suck it up and do it again. If a graduate from MIT can't do this, then you're a failure to your entire, all right. And so that motivated me to work harder. My friend Cliff hits the brick wall, calls home to Buffalo, and mom says, Cliff, why are you torturing yourself? Come on home, you could open up a shop repairing televisions. If that's the option, if that's the support, it's 10 times harder for Cliff to go back and suck it up and do it anyway, which he did. But it wasn't as easy for him because he didn't have that kind of support. The decisions that change our lives are decisions that we make on the basis of what our family tells us to do. And they're decisions that are ultimately made by stupid 16-year-old, 18-year-old kids. That's me, believe it or not, when I graduated from MIT. I went to MIT because my best friend went there and it had really good science fiction library. And this has changed my life. How we make these decisions, there's the blind faith that goes into our lives. The human side of making these decisions to be a scientist, the human side that makes you make the decision to stay a scientist, the human side that makes you want to get up in the morning and go face the lab one more day, to face that computer program that wouldn't compile yesterday, to face that laboratory experiment that was not giving you the results you expected, the utter frustration that goes along with that. That human side too often gets mistaken or lost when we talk about the role of science. It's as if, we think that there are Kirks and Spocks, and that we can divide the world into the ultra rational and the totally emotional. Of course, if you actually saw Star Trek, you realize that even Kirk and Spock were not Kirk and Spock. Spock was a mass of emotions, though he was brilliant. Kirk was a very, very devious fellow and very clever. Still, it's on the basis of both reason and gut feeling that we make these decisions. Who we're going to be, what we're going to study, why we're going to study it, why it's worth studying. Given this picture, of course, you recognize that the guy next to Spock, or the guy next to Kirk, is an utterly brilliant character, and that continues to this day. But it was with how I wound up talking to William Shatner is a long story. I won't get. Very, very sharp guy, by the way. He's in his 80s and still has it, boy. But it was a conversation with him that I finally had an insight into a question about science and faith that had always puzzled me. People ask me, science and faith, do you have any difficulties? I have one tremendous difficulty, which is, why would anybody think there was a conflict? Because it was out of my faith that I believe that science can work, and it's out of my faith that I can justify doing science. But talking to him, I suddenly realized that he had a completely different idea of how science and faith work. First of all, he thought science was a big book of facts. And then religion would be another big book of facts. And what happens if the facts in one book conflicts with the facts in the other book? The premise, of course, is wrong. Science is not a big book of facts. This is a big old science book. Biggest book I've got. Gravitation by Misner, Thorne, and Wheeler. It is the textbook that I use to learn general relativity. Notice something odd about the cover. The cover has a magnifying glass and an apple. One of the glorious things in this book is they're attempting to show the idea that general relativity says that gravity is the warping of space and time. They give the picture, imagine if you're an ant walking on the surface of an apple, and you walk keeping one foot in front of the other, trying your best to walk in a straight line. But as you get close to the stem, the surface is bent inwards, and so anybody looking from the outside, it would appear that your path was bent towards the stem, and then as you left, bent away from the stem, even though you thought you were walking in a straight line. Curved space looks like a force. Looks like, in fact, the force of gravity. Now, the universe is not an apple. We are not ants. But this illusion, this image, allows us to understand how curved space can actually behave, the way that the equations say. Interesting thing is, it's not literally true. Science is not literally true. The equation that describes the fall of an apple is like, gives you let's try this again. The fall of an apple, the path of the fall of the apple is like the solution to an equation that a physicist has set up to describe these things. But the equation isn't the law of physics. The equation is just our best guess at, our best approximation of the law of physics. Physics does what physics wants. Our physical laws are bits of poetry. What does the word like mean? It means it's a simile. My gravity is like an apple falling. My gravity is like this equation. Physics is expressed using analogies. Knowledge is expressed and developed by having many analogies so that you see a new phenomenon and you can say to yourself, this reminds me of something that I understood over there, but my colleague says, that also reminds me of this other thing. How can we put these two different descriptions together to come up with a more rich description of the phenomenon on the basis of things we already understand? That's how knowledge develops. That's how knowledge develops in theology as well. God is like a father. Well, but he's more than that. He's not the same thing as a father, but he's like a father. God is like a wind blowing across the chaos. It's the way it's described in the beginning of Genesis. There isn't actually a wavy chaos, there isn't actually a wind, but God's like that. How else can you describe God except with poetry? Because no words would be adequate to describe it. The other thing about the scripture, of course, is, first of all, scripture is not a science book. That Misner Thornton Wheeler book I showed you, that's from the 1970s. I don't know if anybody uses it anymore. The science has developed beyond that. This book, the Bible, is from 3,000 years ago, parts of it, and we still use it. The difference is that a physics book, a biology book, you guys, you've got kids going to school. Would you give your kid the same biology book you used when you were in high school? Absolutely not. Biology goes out of date. We've learned more since then. We've changed the language we use to describe biology. A biology book, a science book, is a book about a phenomenon. But a book like Shakespeare, sure, you could loan your copy of Shakespeare to your kids, because Shakespeare isn't a book about something. Shakespeare is the thing. Plato is the thing. Scripture is the thing. And what is the thing in Scripture? It's an expression of God's presence on earth. It's a book about God. It's not a book about it's a book about God. And what it has to say about God maintains its truth even as our understanding of how the world works keeps changing. Because what does Genesis say about how God acts in the world? Unlike the Babylonians who thought the universe was a mistake, Genesis says the universe was the deliberate act of a loving God who decided ahead of time, outside of the universe. In the beginning, God said, in the beginning, God's already there before space and time have been invented. God said, he deliberately decides to say something. And he says, let there be light, because he's not doing anything hidden in the dark. He's doing this so that everyone can see what he's doing. And he's doing it in an orderly way. We call it 7 days. And he's doing it in a way that allows us to follow what he's doing. And at the end of every day, he goes, this is good stuff. This is worth studying. There's a whole thing I was going to talk about this picture, except it's a beautiful picture. It's the road to Emmaus. It's appropriate for this week. But beyond that, there's something else going in science that I want to talk about. And this goes to my times in the Peace Corps. Back when I was in the Peace Corps, we did training 80 people. We're all sort of gung-ho, we're going to save the world together. And one of the things we played was this game called Hacky Sack. Let's see if I can get the video to... Oh, no. Come on, let's do, can I get this to run? There we go. So the idea is you got a bean bag, and you kick it around, and you try to make sure that the bean bag doesn't hit the ground. One of our volunteers had her boyfriend from New York City show up for a weekend. And he's watching us playing this crazy game. And he goes, wait a minute, you're not knocking each other down? No. You're not scoring points? Well, no. You're not, competing with each other? How do you win this game? It was bizarre that he could conceive of a game that didn't have winners and losers. Science is a game that shouldn't have winners or losers. How do you win this game? Again, a wonderful cartoon. What's your ambition when you start graduate school? To win the Nobel Prize, revolutionize your field, get a job, hope they have pepperoni pizza at the next colloquium. What is it that drives you to go and do the work you want to do? What's your personal goal? What counts as winning? There are a lot of obvious criteria that a university might have to tell you what's successful and what isn't success. The kind of thing that'll give you tenure. You want the approval of others. You want people who are going to give you nice letters of recommendation. You want tenure. That means, okay, you've actually got a permanent job. You've won. Maybe you want grant money. Maybe you want prizes, the Templeton Prize, the MacArthur Fellowship, the Nobel Prize. Maybe it's enough to just get your name in the New York Times. You did something that was famous enough that people will remember you for a minute and a half. Maybe it's kind of like parenthood, and a sign of success is having successful students. Well, how it makes them successful? Because they got grant money or prizes or something like that. Maybe it's just, did I write papers that other people use? The more papers, the more citations. It's an interesting kind of economy. It's an economy not based on how much you got, but how much you've given. The more you've given that other people accept, the higher your prestige. There are other carrots that might make you want to be a scientist. Maybe you're looking for a place where you have total academic freedom. Maybe you're successful when you can decide what's the science that your field is going to follow. That you're so successful that you're on those committees who decide this is what we're going to fund in the next 10 years. Maybe the fact that you're not tied to what NASA is going to pay for, NIH is going to pay for, maybe that means you've won at being science. But it begs the question, what is it about getting to do science that makes that a reward in and of itself? What of these things are in and of themselves? This is the table of contents of a journal, Science, from 2013. One of the top journals in the field. If you get a paper published in Science, it's a big deal. It's a sign of success. Do you wake up in the morning and jump out of bed and rush to the lab because, by golly, you hope that you can be one of the et al. Authors that don't even show up in the table of contents? That's going to tell the world something really new and radical and exciting about the effect of collective molecular reorientations and Brownian motions of colloids in pneumatic liquid crystals. Which turns out actually is an important piece of work. It was cited 20 times in the next 3 years. Is that what motivates you? Is that what gets you up in the morning? How do you win this game? What are the personal motivations that work on you to do science? Curiosity? Pleasure in solving problems? Pleasure in finding patterns? Maybe you've got this, I've got to find the truth. Maybe you're doing it out of love. If we didn't love the work, we wouldn't do it. And God is love, right? So, let's pit the one against the other. If you're on a committee trying to hire somebody, are you going to hire the one who has the grant money, the prize, and the fame, or the one who finds pleasure in finding patterns and shows curiosity? You know which one they're going to hire. And you'd have a hard time arguing with that choice. Let's put it another way. If these are the criterion that are important to you, and you've got to make a choice, which list would you sacrifice? Would you sacrifice anything on list 2 to avoid losing anything in list 1? Would you give up the approval of others to satisfy your own curiosity? I'm really curious about this little phenomenon. Nobody else cares about it. Well, am I going to spend the next 2 years of my life following and studying this one thing that nobody else cares about? Science is the conversation. If you don't have anybody to have a conversation with, you're not doing science. Would you give up tenure in order to do the stuff you love? Well, maybe you're not so fast to do that if you've got a wife and family or a husband and family, and you've got to be able to support them. Would you give up academic freedom, the freedom to pursue whatever research you want to do, in order to have a really cool place where you can just solve problems, which is really fun to do, even if they're not the problems you pose? In other words, do you work at a small, underfunded department in a little college, or do you work for a big corporation that has a really deluxe playpen that you can play in, but doing the problems that they're willing to pay for? And everybody's going to have a different answer to that. Would you give up fame in order to just go off finding patterns? Would you give up finding patterns because you want fame? Would you give up grant money in order to find the truth? Where's your heart? Where's your God? And what does this tell you about the kind of God you worship? Internal motivations aren't enough. Before you jump to one conclusion, oh, I would always pursue truth. Well, if you're not getting paid to do the work, you can't do the work. You know, if you can't eat, you can't do any work at all. And if you're not doing work that the culture will support and respect, you're not going to have anybody to have a conversation with. And without that conversation, it isn't science. Internal satisfaction isn't enough. Something else is the ultimate criterion for how you choose to do science. And if you lose sight of that criterion, then the work you're doing becomes meaningless. You're just doing a job. You might just as well, drive the trolley. And there's nothing wrong with that. One of the great astronomical photographers in Britain has a day job driving the subway car, an underground car, on the district line. And that pays him enough that he can go off and buy the equipment to be an astronomer at night. That's how he solved that problem. On the other hand, if you don't have the internal motivations, then you're not going to get up in the morning and want to do the work. And I say that criterion is ultimately a personally religious criterion. The motivation to actually make you want to do that work. And I, in my own life, reflecting on these questions, have decided that the criterion ultimately is joy. Let me show you joy. Joy is seeing a universe that not only makes sense, but is beautiful. A universe where the subtle colors not only are beautiful, but are also telling you a story about what's going on. When I look at this wonderful thing, part of me sees a unicorn, and part of me sees pillars of gas that have been compressed by a nearby supernova, and at the tip of those pillars are regions that are now super dense relative to the other spots, disks of gas that will be turning into new planetary systems. Like a unicorn. Both of those things I see, and it makes me happy. There's actually a movie you can get of this particular star, and it looks like the thing is exploding. But actually, it's merely a pulse of light which is illuminating different shells as time goes by. And it's so big that it takes months for the light to go from the original star out to the different shells of gas. And sometimes nature is just crazy. And sometimes nature is phenomenally beautiful. That's a galaxy. And the spiral around it is another galaxy that has passed through that first galaxy and been ripped apart, and the stars in the second galaxy are now orbiting around the center of the first galaxy. So we're talking thousands of light years from one end to the other. But it's not only at the large scale, it's the small scale. This is a thin section of a meteorite, one of the things I work with. That round thing, that chondrule, is less than a millimeter across. These images are joyful. What I really have a hard time communicating, though, is the joy that comes from understanding. I remember once about 10 years ago, I taught for a year at Fordham University. I was teaching a bunch of kids who were doing pre-meds. I was teaching them basic physics, and I had some really bright kids in this class. And we were talking about Maxwell's equations. Maxwell's equations basically look like that. And I worn that short, and I said, by the end of the class, you'll get the joke. You'll also know what all of those symbols mean. And I had Maxwell's equations on the blackboard. And I said, well, Kurt, this is the integral form, but in fact, you can do an inversion of this in the differential form, and the derivatives are very good because you can manipulate them mathematically. And if you take the derivative of the first one with respect to time and the derivative of the second one with respect to space, then suddenly you've got common terms that you can merge together, and you can squeeze the equations into two identical equations, one for the electric field, one for the magnetic field, that shows that the change of the magnetic field with time is equal to a constant times the change of the magnetic field in space. Yeah. Well, there was a kid in the front row who looked at that equation. And he looked at it, and before I could get to the punchline, that makes the shirt make sense, he got there ahead of me. And he goes, oh my God, it's a wave. Yeah. The equations tell you that electricity can propagate itself through empty space like a wave. And magnetism, at the same time, is propagating itself through space like a wave. And that constant, I can work out that constant from the little terms there, the mu sub zeros and the e sub zeros. I've measured those in the lab. When you put that together, that should be the speed of the wave squared. And the speed of the wave is the speed of light. What travels at the speed of light in a wave? A light wave. And with this set of equations, Maxwell understood what light was. But more than that, there's a fellow who was very skeptical in Germany, a fellow named Hertz, who said, yeah, if that were true, I should be able to make a low energy wave over here and maybe a piece of wire over here that would pick up that wave, right? And he tried it, and it worked. And we say the frequency of the wave is now measured in hertz. And a fellow in Italy said, if I could do that and send out these waves in every direction, in every radial direction, well, the Italian word for radial is radio, suddenly we've got a way of communicating. And Nikola Tesla says, we could use these equations as a way of transmitting energy from a dam and generator in Niagara Falls and send the electrical energy without loss all the way to New York City. And that's the high energy grid that, runs our electric grid to this day. And everything in electronics comes out of these equations. And they're really exciting. But all of the things that you can do are nothing like that burst of joy, that oh my God moment that the kid had, that I had when I was his age, when you suddenly realize that a bunch of things you had no idea were related to each other all meshed together in this incredibly beautiful way. Why do we do science? Ultimately, I think it's for that burst of joy. Why does the Vatican support science? Yep, no, come on back. I will make this work.
Why does the Vatican have an astronomical report? For instance, you're the curator of meteorites at the Vatican. Why do they curate meteorites? Are they looking for the shooting star of David?
No, in fact, the whole idea of having astronomers really got started with the
since then, just studying the universe is a great way to remind yourself that there's more important things in life than what's for lunch.
What is going on?
I'll end with one story here. When I was a little kid, we spent our summers in a summer cottage in the shore of Lake Huron. And you can see the porch there with the flaps open. Great place, especially when it was raining, you could at least be kind of outdoors. I remember a rainy Sunday afternoon, couldn't go out to play, I was maybe 10, 11 years old. And my mom pulls out the deck of cards and, deals out a hand, we're playing rummy. I don't remember anything else about the game, I just remember that little scene as one of those bits of memory from childhood that you never lose. And I think back on it now, okay, I'm a kid, she's a grown-up. If the game was to win the game, she could have won all the time. But that's not why she was playing the game. For her, playing the game with the kid is her way of telling the kid she loves him. And a 10-year-old, you're not going to, if my mom came up to me and said, son, I love you, I'm going to go, Mom. But this very concrete, just spending time, sharing the joy, the little bit of discovery we get in a simple game that a kid can play. That's how I feel when I'm in the laboratory. I'm playing a game with God. God has set up the puzzle. It's up to me to solve it. And when I get some progress made, I can hear him going, yeah, isn't that cool? Now let me show you the next step. That's why doing science is an act of worship. It's an act of love. It's God revealing himself in the universe. And without that, I wouldn't do science. Science needs that faith. It needs that joy, or it wouldn't happen. Thank you very much for coming. So I've got a little time for questions. Not too many. I've been working all time today, but I expect 5-10 minutes. And any questions you have about the topic or about working at the Vatican or, what does the Pope have for breakfast? I have no idea. Any questions you want, and if I don't want to answer them, I won't. That's easy. Yeah?
When was the observatory built in Arizona?
The Arizona Observatory was built in the late 80s and saw first light in 1993. It was the mirror that they've got there was the very first mirror made with this new idea of spin casting, where you melt the glass in a rotating oven. You want a telescope mirror to gather a whole lot of light, so you want it to be like a big bucket with the rain coming in, and then to focus that light so it's got to be curved like a parabola. And the old-fashioned way is you get a big chunk of glass and you carve and you carve and you carve, and you hope you don't break the glass. But a fellow named Roger Angel came up with this idea in the late 80s. If you melt the glass and you spin it, the spinning causes it to flow out into the shape of a parabola. And you can put little blocks underneath it to make it, a honeycomb and very lightweight, relatively speaking. He made one mirror, came to the Vatican Observatory, which had an outpost in Rome, in Arizona, to basically use Arizona's telescopes. And they said, we'll give you the mirror if you build a telescope around it. So that's what we've done. The nice thing is that because Roger Angel provided this mirror to us, we can now say that the Pope's telescope has a mirror made by an angel. The observatory itself dates to 1891, and as you saw in the movie, we claim our history going back to the reform of the calendar in the 1500s. Yeah, other questions? Yeah.
I almost hate to ask this question, but one of my great life's heroes died 6 months before I was born. He died in April of 1955, and that was Teilhard
de Chardin, yeah. And you're the reincarnation of him, that's what you're saying.
He ratified my developing faith as a Catholic when my Catholic catechist was saying, no, the earth was created in 7 days, and that's...
That's heresy. Your catechist was a heretic.
Well, I thought that, and my father said when I was about 6 or 7 years old, don't fight him too hard. hard, wait for another 7 years, and I will teach you about Desjardins, which he did.
Excellent.
So, of course, the history, as you know, about Desjardins was he was a Jesuit, born in, he was actually a scientist, then he was a Jesuit in France, and the Jesuits in France were unhappy with his science, and they sent him to China, and they sent him to Africa, which, of course, just substantiated his work as an anthropologist. He died in 1955 on the wrong side of the Jesuits. So
Well, they buried him in a Jesuit cemetery.
They did.
Yeah,
They did.
yeah.
They didn't excommunicate
No.
anything, but they probably were not too sad.
Well, I'll tell you a story about Chardin in the 50s. The previous director, two but back, a fellow named George Coyne, the director when I came in, was studying theology in the 50s as Chardin's books were decided to be very, very dangerous. The director of the theologate called in all the young priests or priests-to-be who were scientists. And he said, we've gotten word from Rome that these particular books are dangerous. So I'm going to put them on this shelf right here to make sure you don't get them by accident. In other words, oh yeah. And of course, Chardin is now considered one of the great theologians of the 20th century. Popes quote him all the time.
Needed to know that
Yeah.
the Jesuits made peace with them.
Oh yeah, absolutely. And you know, the Jesuits are not monolithic. We've got 15,000 Jesuits, which means there's 30,000 opinions about anything. This past fall, I was one of 200 of them that were at a general congregation where we elected a new Father General. And you could see the whole range of opinions, and also how the opinions would shift back and forth, because we're always excited about new ideas, even as you're suspicious of them. And it's like being a scientist. Just because the idea is new doesn't mean it's right, doesn't mean it's wrong. It does mean that it's not tested, so let's test it. Yeah.
There used to be work at Gandolfo on iron lines, calibration of thousands of iron lines. Sometimes I looked it up as a student. Is that existing still?
Oh, we don't do that work anymore because the work's been done.
It's been done.
Okay, the question is, with the work that we used to do in Castel Gandolfo was measuring of the spectral lines of iron, and not only iron, but other metals.
That was a question.
And so that was the question, is it still being done anymore? The answer is, that work was completed. It started in the 1930s. They actually started their own journal, Spectrochimica Acta, which is still being published by Elsevier. After the war, the journal was even printed in the Vatican because it was the only outfit in Italy and in Europe that had the printing press that survived the war. That work was done by a very dedicated group of German scientists, German and Dutch scientists, who stayed and continued that work during the war and supported and protected refugees as the Nazis were. It was a fabulous story in the history of astronomy. But all of that work was essentially completed by about 1977. And at that point, the guys who had started doing it in the 30s were all of retirement age. And most of them retired, went back to Germany or wherever they were from. But that work still exists. The atlas still exists. That's still the standard that everybody uses, as far as I know. Yeah, in the old days, they want to know, as my work's now published in the Proceedings of the Specola Vaticana. In the old days, every observatory had its own annual publication where you would print your scientific papers. That's not done anymore. Instead, everybody publishes papers in whatever journal is appropriate to their field. And so I publish my papers in a journal called Icarus, or a journal called Meteoritics and Planetary Sciences. Those are the two that I've been published in. Or, you know, if it's something exciting, Nature or Science. Other members of our team would publish in the Astrophysical Journal, or in Physics Review B, or whatever is appropriate. And none of us do science on our own anymore. Every paper I publish has, you know, authors from around the world. The last really important paper, I had a co-author from Italy, one from Japan, one from Russia, one from Greece, one from Switzerland, and one from Germany. And that's what the world is like nowadays. Everybody collaborates with everyone else. No one person knows enough to be able to do the science. We have to have these conversations. We have to work together. But the work that was done that you remember from the 30s and 40s and 50s is the basis for work that we and other people are continuing to do. And it has not been lost, it hasn't been forgotten. And it's greatly honored. One of the things I might want to mention is the kind of work that we can do at the Vatican, which is different from the work I did back in the days when I was at a university and being paid out of a NASA grant, is this. When I was being funded by a NASA grant, I had 3 years to produce something. And then the grant was going to be over, and if I didn't have anything to show for it, I wasn't getting any more money. When I was at Lafayette College, I had, in theory, 6 years, and then I was going to be up for tenure. It meant that I had to choose questions to work on that would have an answer in 3 years. This atlas of the spectral lines of iron took 10 years to do, to develop the laboratory, to put together the equipment, to do the measurements, to find out that wasn't going to work, we've got to do it this other way. That could not have been done under modern funding, but it was easy to do at the Vatican because we don't have a deadline. The research that I've done at the Vatican has been a survey of the physical properties of meteorites, again, taking about 10 years to have the first results that were of any use to anybody. I could never have done that if I was up for tenure, but I don't have to worry about tenure. So I can do the work that complements the work that everybody else does. Everybody else is using the tables of data that we've put together. And that means that we have a really nice and important niche in the world of science. We're not so much in competition with other observatories, but we complement what other observatories can do. Yeah, in the back.
I'm not sure what words to put this in, but I'm interested in what is the observatory's connection to the Pope? So what products do you
Sure.
use, or what advice do you give?
Yeah, how do we connect up with the Pope? I'm just learning this myself as the new director. The observatory was founded by a motu proprio, which is basically a letter, of Pope Leo XIII. So it's a creation of the Pope. Now the Vatican, the way it's organized nowadays, since the invention of the Vatican city-state in 1929, there's the Pope at the top and 2 parallel chains of command. There's a cardinal who's in charge of the church side, who ironically is called the Secretary of State. And there's the cardinal who's in charge of the state side, who's called the President of the Governatorato, the government. The funding for the observatory is as a part of the government. So the observatory on the organizational chart looks like, oh, it's next to the place that prints stamps and coins, and the place that runs the museums, and the place that runs the pharmacy. Except the observatory was actually invented in 1891 before there was a city-state. So we're negotiating right now, really, how do we want to fit in their organization chart? The one thing for sure is that I was appointed by the Pope. I was not appointed by one of the cardinals. And only the Pope can fire me. Though if people tell him to fire me, he probably would. So I can't rely on that. We publish an annual report, not as a series of technical articles anymore, but a summary of what we do. And we write this up both in Italian and in English so that they know what we're up to. But really our mission is to help show the world that the church supports science. And as long as we're doing that, as long as we're bringing in good PR, as long as we're doing the sort of thing that makes you happy to be a Catholic rather than embarrassed to be a Catholic, then we're fulfilling our duties to him. It's not like, the Pope wrote this encyclical, Laudato Si. Fabulous piece of work that has a lot of really good science in it. And as far as I know, none of us had anything to do with it. He had his own people who would speak Spanish and people he was familiar with from his times in Argentina. Previously, Pope Benedict had scientists who had been students of his in Germany. Previous to him, Pope John Paul II would have a meeting every year of academics, because he had been an old professor himself, from Poland. And they would speak to him in Polish. This is what's going on in the world. They're the ones who have his ear. So we don't pretend to have that. I don't, rub shoulders with the Pope. That said, the Pope knows who I am. When I show up at an audience, he recognizes me. I think maybe the beard helps. It's kind of scary to know that the Pope knows who you are by name. But I don't want to exaggerate, just how close we might be. The previous director was from Argentina, and he knew the Pope back when they were both Jesuits together in Argentina. And Francis has actually had lunch with us one time when soon after he was elected. So he's familiar with what we do and who we are. But we're not advising him every day. This came up, actually, an interesting thing recently. There's new streetlights being installed in Rome right now, which are these ugly, horrible LEDs that have these really bright blue lights, and they're miserable for stargazing and lots of other things. And somebody said, can you talk to the Pope about this? Probably not. But what I can do, and what I did do, was to write an article about it, which appeared in L'Osservatore Romano, the newspaper at the Vatican that everybody reads. So they now know what I think about these lights. You do what you do. Yes?
As a scientist, have you ever become curious, like NASA, constantly searching for if there's another planet just like Earth with Earthlings?
Mm-hmm. The way that question is usually asked is with a slightly different twist. Do I believe that there are, intelligent beings out there? And the reason I like that question, do I believe, is because at the moment it's a matter of belief. It's a matter of faith, not a matter of science. I don't have the data yet. But I think the likelihood is high enough that if somebody at the observatory wants to spend some time studying that, to look for those sort of things, I'm not going to stop them. I think the likelihood is high enough that when the SETI Institute, the Search for Extraterrestrial Intelligence Institute in California, invited me to be on their board of scientists, I said, yeah. So, I participate as far as that is concerned. I think the idea of life in other planets, well, where people really think it's likely to be now is not necessarily in Mars, but in the oceans underneath the ice crusts of the icy moons of Jupiter and Saturn. I wrote about that in my master's thesis at MIT in 1975. I did not predict life in the oceans. What I actually said was, I will refrain from predicting life in these oceans and let somebody else make that crazy idea. So I'm the first person to not predict life in the oceans. I don't have the data, but I'm excited about the possibility. And if it's there, what are the theological implications? I have no idea. I've written a book about it. Doesn't mean I know what I'm talking about. But what I do know is that asking the question, what would baptizing an alien mean, makes me ask the question, what does baptizing me mean? What does baptism mean? What is the source of this need of redemption? Oh, sin. What is sin? Sin is choosing to not do the thing you should be doing. How can you do that? If you've got free will. If these aliens have free will, are they going to be able to sin? Probably. Are they going to need some kind of redemption? Probably. Will it look like our kind of redemption? I have no idea. The only data I have there are the stories we have about angels, who are definitely not human beings, but in our stories had to make a choice for or against God. And they have a redemption different from, and a redemption story different from the human story. So I'm not going to sit here and tell you God had to do it that way. But I am going to say, without the data, I still find the idea exciting enough that I'd love to learn more. And I hope someday we do find something. But what that's going to look like, when that's going to happen, no idea. I think I mentioned I got into this whole field from reading science fiction in the first place. Science fiction tells me about people having adventures. Where do people have adventures? On planets. So I studied planets. And that is an example, I think, of the joy and the love and the fun that makes you want to do the science. Because the science is good, hard science, but the intrigue of the question makes the hard work all worthwhile. Yeah?
So I don't know if this is a silly question, but what are the new and upcoming things to study right now for you?
Until you said for me, I thought that was going to be an easy question.
For the world.
Right. There are, I think, some big questions that are always going to be out there. What is dark matter? What is dark energy? The nature of the universe. We now know that 95% of the universe is made up of stuff that we don't understand, that we didn't even know existed 50 years ago. And that's exciting. What is that stuff? How do you even learn? It's like a big mess of yarn. Where's the first thread that you pull on to try to unravel it? We're still at that looking for the first thread stage. 50 years ago when I started studying this stuff, we had a great idea of how planets worked, and that great idea of how planets were formed made predictions. You'll always find this kind of planet, you'll never find that kind of planet. Now we've discovered 2,000 planetary systems, and none of them look like ours, and none of them match the things that we thought our theories predicted. That's exciting. That's really wonderful. And I'm not going to live long enough to see how that's all going to play out. But that's exciting. On a smaller scale, there's a guy who had attended our summer school. We have a summer school every 2 years where we bring in 25 students from around the world. This guy was a summer school student in '93. He's now running a project to coordinate observations of microwaves coming from the center of our galaxy, hoping to see the outline, the shadow of the massive black hole in the center of the galaxy. And if we can actually get a size and a shape of that black hole, then we can test theories of general relativity, maybe find out if we have to fix that book. That's exciting. So and I've just named the top three off the top of my head. There is so much that can be done. And the reason there's so much that can be done is because there's so much that has been done. My dad, who I love dearly, turned 99 last week, and is still going strong. But I remember when I was a kid, we'd share these conversations, riding to the Jesuit high school in Detroit. And one I'll never forget, he says, knowledge is like an island. The more you know, the bigger your island in this vast sea. But the bigger the island, the longer the shoreline. And the shoreline is the boundary between what you know and the ocean of what you don't know. And the longer the shoreline, the more you realize you don't know. And that means we'll never run out of things to study. We'll never come up with final answers. That's not what the goal of science is. In some ways, the goal of science is to expand that shoreline, to discover new and exciting things to study. But if you ever find somebody who thinks he knows everything, it's because his island is really, really tiny. Thank you, everybody, for coming.